discuss very important topic, that is in trigonometry, that is periodicity and extreme values. Periodicity and extreme values. Yes, today's topic is, that is periodicity and extreme values. Extreme. Yes. So this chapter name is what? Periodicity and extreme values. So observe here, periodicity. First we discuss periodicity. After that we will discuss extreme values. Periodicity means which are the periodic functions. First of all, function means if A and B are two non-empty sets. If A and B are two non-empty sets. If A and B are two non-empty sets. F is the relation from A to B. F is relation from A to B. Then F is called function from A to B if every element in set A, associated with unique element in set B. Then F is said to be function from A to B. That function means, first of all, function means A and B, let A and B are two non-empty sets. Let A and B are two non-empty sets. Come on. F is relation from A to B. Come on, F is relation from A to B. Then F is called. F is said to be function. Then F is said to be function. F is said to be function from A to B. F is said to be function from A to B if every element in set A, if every element in set A associated with unique element, every element in set A is associated with unique element in set B. Then F is said to be function from A to B. So here, function means let A and B are two non-empty sets. F is relation from A to B. F is having the relation from A to B. Then F is called, or F is said to be function from A to B if every element in set A is associated with unique element, at least one element, that is unique element in set B. Unique element, that means exact one element in set B associated with only one element in set B. Then the F is said to be function from A to B. It is denoted by F maps A to B. It is denoted by F is mapping from A to B. That is F is function from A to B. F is function from A to B, or F is mapping from A to B. F maps A to B. It has F maps A to B. Here A is called what? A is called domain of the function. called what? Domain of the function, and B is called codomain of the function. Codomain. Domain of the function, A is called here what? Domain of the function, and B is called codomain of the function. B is called what? Codomain of the function. Then observe here, function means that A and B are two non-empty sets. A and B are two non-empty sets. F is a relation from A to B. Then F is called a function from, or F is said to be a function from A to B if every element in set A. That means every element in set A. That means 1, 2, 3. Observe here. Every element in set A associated with unique element in set B. That means A, B, C, D. Every element in set A. Every element set A associated with unique element in set B. Every element of set A associated with unique element in set B. Then F is called function from A to B. F is called function from A to B. This is it. F is called function from A to B. Every element in set A associated with unique element. Unique element is single element in set A. Associated with single element in set B. Then F is called here function from A to B. Function from A to B. Here A is called what? A is called domain of the function. A is called what? Domain of the function. And B is called codomain of the function. A is called what? Domain of the function, and B is called codomain of the function. Codomain of the function. Then observe here, f of x such that the set of f of x belongs to A. F of x such that x belongs to A is called range of the function. Range of the function. That means the set of actual images in set B, are called what? Actual images in set B are called range of the function. Observe here, the range of this function is here A, B, D. A, B, D are the range of the function. So, range of the function is always subset of codomain. Range of the function is always subset of codomain. Range of the function is always subset of codomain. Observe once again. Function means if A and B are any two non-empty sets, and F is relation from F is relation from A to B. F is relation from A to B. Then F is said to be. Then F is said to be function from A to B if every element in set A associated with unique element. Every element in set A associated with unique element in set B. Then F is said to be function from A to B. It is denoted by F is mapping from A to B. F is mapping from A to B. F is function from A to B. Here A is called domain of the function. A is called what? Domain of the function. And B is called here codomain of the function. Codomain of the function. Then here observe here, this is domain of the function and this is codomain of the function. The set of actual inputs, that is A, B, D, are called range of the function. That means the set f of x, set f of x such that x belongs to A. F of x such that x belongs to A is called the range of the function. Is called what? Range of the function. Next, periodic function means let us discuss periodic function. Yes, periodic function or periodicity. Periodicity means, observe here. First discuss periodicity. After that we discuss extreme values. First of all, periodicity. What is the definition of periodicity? Periodicity. Periodicity means the real function f maps, f is mapping from E to R f is mapping from E to R, is said to be periodic function f maps E to R is said to be periodic function if there exists a positive real number, if there exists a positive real number, if there exists a positive real number, also the real function f maps E to R, that means E is subject to R, f maps E to R is said to be a periodic function if there exists a positive real number such that satisfy one condition, that is f of x plus p is equals to f of x, such that f of x plus p is equals to f of x for all x belongs to E, then the least positive value of p, is called period of the function. Observe here, periodicity or periodic function means the real function f maps E to R. F is mapping from E to R. E is the domain and R is the codomain. E is said to be, this function is said to be periodic function. This function is said to be periodic function if there exists a positive real number. If there exists a positive real number such that function is satisfying the one condition, that is f of x plus p. F of x plus p is equals to f of x. F of x plus p is equals to f of x. This function is satisfying this condition, then the least positive value of p is called the period of the function. Then the function is called periodic function. Periodic function. Once again, observe here, periodicity or periodic function means, observe here, the real function f is mapping from E to R. That means domain of the function is E and the codomain of the function is R. F is mapping from E to R. This function is said to be periodic function. This function is said to be periodic function if there exists a positive real number p. If there exists a positive real number p, such that f of x plus p is equal to, there exists a positive real number p such that f of x plus p is equal to f of x. They satisfy the condition, that is f of x plus p is equal to f of x. For all x belongs to E, this is domain. X is every element is domain. That is x belongs for all x belongs to E. For all x belongs to E. That means every element in domain satisfy the condition, that is f of x plus p is equal to f of x. F of x plus p is equal to f of x. Then the least value of p is called the period of that function, and the function is called periodic function. Here the function p value, it has so many values, that means it has infinite values, but we want the least value, the least positive value, The least positive value of p is called the period of that function. Is called the period of that function, and this function is called periodic function. If satisfies this condition f of x plus p is equals to f of x, then the function is called periodic function. Then here p is called, the least value of p is called what? Period of that function. Period of that function. Observe here, periodic function or periodicity means a real function. The real function f maps e to r, f is mapping from e to r, is said to be periodic function if a positive, if there exists a positive real number p, if there exists a positive real number p such that satisfying the condition f of x plus p is equals to f of x. F of x plus p is equals to f of x for all x belongs to e. Observe here, for all x belongs to e means every element in the domain satisfies this condition. F of x plus p is equals to f of x. Then the function is called periodic function. The least positive value of p, positive value of p is called the period of that function. The least positive value of the p is called what? Periodic function. Let us discuss one example here. That is one theorem. Yes, let us discuss one theorem here for understanding this concept, that is theorems. So that the sine function is periodic. The sine function is periodic, and the period is 2 pi. The sine function is periodic function. And the period is 2 pi. The sine function is periodic function and the period is 2 pi. Proof, observe here. Proof. The sine function is periodic function. Periodic function means the satisfy the condition that is f of x plus p is equals to f of x. For all the value of x belongs to e, f of x plus p is equals to f of x. Then the function is called periodic function, and with the period is p. Observe here, the sine function is periodic and the period is how much? 2 pi. So observe here, that is f of x given function f of x is equals to clearly sin x. Given function f of x is equals to sin x. F of x plus p. Now f of x plus p is equals to how much? F of x plus p is equals to sin of x plus p. Sin of x plus p. If sin of x plus p is equals to sin x, that is, if f of x plus p is equals to f of x, then the sine function is what? Periodic function. With the period is how much? They gave the period is 2 pi. Observe here the sine function, let if p is equals to take pi by. We prove that the period is 2 pi. If any value of p, that is pi by 2 or pi or 3 pi by 2, if satisfy the condition, once again check, after that we use this 2 pi. Observe here, if p is equals to pi by 2, then that is equals to f of x plus pi by 2. F of x plus pi by 2. F of x plus pi by 2 is equals to, that is clearly sin x plus pi by 2. Sin x plus pi by 2. What is the value of sin x plus pi by 2? Sin x plus pi by 2, that is sin 90 plus theta. Sin 90 plus theta. Sin 90 plus theta means clearly it is second quadrant. In second quadrant, sin is positive and sin ratio changes into cos ratio. So we get cos x. So f of x plus pi by 2 is equals to cos x is not equals to f of x. So pi by 2 is not a period of a given function. Pi by 2 is not a period of the given function. If p is equals to take pi. If p is equals to pi, then f of x plus pi. F of x plus pi. In place of p, substitute here f of x plus pi is equals to f of, that is f is sin x plus pi. Sin x plus pi. Sin x plus pi means clearly sin 180 plus theta. Sin 180 plus theta, clearly 180 plus theta, clearly it is in third quadrant. In third quadrant, sin ratio is all silver teacups, tan and its reciprocal cot are positive. Clearly sin is negative. So we get that is equals to minus sin x. 180 is there, so sin is not at all changed. So sin is sin function only. So we get minus sin x. So it is also f of x value sin x. So not equals to f of x. Not equals to f of x. Clearly f of x plus pi. F of x plus pi is not equals to f of x. So pi is also not a period of the function. And if substitute p is equals to 3 pi by, if substitute p is equals to 3 pi by, that is f of x plus 3 pi by 2. X plus 3 pi by 2 is equals to the function clearly sin function sin of x plus 3 pi by 2. Sin of x plus 3 pi by 2 is equals to 3 pi by 2. 3 pi by 2 is nothing but 270. Sin of 270 plus theta. Sin of 270 plus theta, clearly it is in third quadrant. 270 is there, so sin ratio changes to cos ratio, and in fourth quadrant 2 plus 270 plus theta lies in fourth quadrant. In fourth quadrant sin is negative, so we get minus cos x. Is not equals to f of x. Is not equals to f of x. Is not equals to f of x. Right, substitute here p is equals to, if p is equals to 2 pi, if p is equals to 2 pi, that is equals to f of x plus 2 pi. F of x plus 2 pi is equals to f of x plus 2 pi is equals to sin x plus 2 pi. Sin x plus 2 pi. Sin x plus 2 pi. 2 pi means clearly 360 degrees. Sin 360 plus theta. Sin 360 plus theta lies in first quadrant. In first quadrant, all the trigonometric ratios are positive and 360 is there. So sin ratio not to be changed. So we get sin x. Sin x. That is sin x. Sin x. Sin x is nothing but f of x. Sin x is nothing but f of x. So here f of x plus 2 pi is equals to f of x. F of x plus 2 pi is equals to how much? F of x. That means sin x plus 2 pi is equals to sin x. Sin x plus 2 pi is equals to sin x. So clearly sin function is periodic function. Sin function is so sin function is periodic function. Sin function is periodic function. The period of the function is period of the function is how much? 2 pi. So observe here, the theorem is prove that the sine function is periodic function. Prove that the sine function is periodic function and the period is 2 pi. First of all, we check x is equals to pi by 2, p is equals to pi by 2. What is the value of pi by 2? F of x is equals to sin x. F of x plus p is equals to sin x plus p. If sin x is equals to sin x plus p, then the function x sin x is equals to sin x plus p. If you satisfy the condition where the sine function is a periodic function and period is p. If you substitute p is equals to pi by 2, p value pi by 2. So we get cos x is not equals to f of x. So f of x plus pi by 2 is not equals to f of x. So period is not at all pi by 2. If you substitute pi, we get minus sin x. This is also not equals to f of x. If you substitute p is equals to 3 pi by 2, so f of x plus 3 pi by 2 is equals to, we get minus cos x. This is also not equals to f of x. If you substitute p value 2 pi, we get f of x plus 2 pi is equals to sin x plus 2 pi, we get sin x, that is equals to x. That means we satisfy the condition f of x plus p, f of x plus 2 pi, f of x plus 2 pi is equal to f of x. F of x plus 2 pi is equal to f of x. So sine function is what? Sine function is periodic function. Sine function is periodic function. The period is 2 pi. The period is how much? 2 pi. The period is 2 pi. Clearly, here, if you substitute 4 pi, we get same answer, sin x only. If you substitute 6 pi, f of x plus 6 pi also we get sin x only. F of x plus 8 pi, 10 pi, and so on, we get same answer. But they gave one condition, the least positive value of p, the least positive value. That means compulsory p value is lying between 0 is less than, not less than or equal to. Why? Because the positive real number. So 0 is less than p is less than or equal to 2 pi. 0 is less than p is less than or equal to 2 pi. Then the value of p, the least value of p is called the period of the function. The least value of the p is called the period of the function. That means p is always lying between 0 is less than, p is less than or equal to 2 pi. So observe here, f of x plus 6 pi also we get sin x only, 8 pi also we get sin x only, 10 pi also we get, and 12 pi and 14 pi same answer. But we want the least value of p. The least value of p is called the period of the function. Least value of the p is 2 pi. Not a pi by 2, not a pi by 2, not at all get the same answer. F of x plus pi by 2 is not equal to f of x. Not a pi. So f of x plus pi is not equal to f of x, and not at all f of p is equal to 3 pi by 2. That means f of x plus 3 pi by 2 is not equal to f of x. So it's sine function satisfies the condition when p is equal to 2 pi. P is equal to 2 pi satisfies the condition f of x plus 2 pi. F of x plus 2 pi is equal to we get f of x. F of x plus 2 pi is equal to f of x. So sine function is periodic function. Sine function is periodic function with the period is how much? Period is how much? That means which function satisfies this condition? That is f of x plus p is equal to f of x. F of x plus p is equal to f of x. Then the function is called periodic function. The least value of the p. The least value of the p is called period of that function. The least value of the p is called period of that function. So period of sin x is how much? Period of sin x is 2 pi. Clearly, period of sin x is 2 pi. So sin function is always periodic function. All the trigonometric functions are periodic functions only. All the trigonometric functions are clearly periodic function. Maybe p value different from different function. That is cos x, that is tan x. Also, observe here, the sine function is periodic function and the period is 2 pi. The reciprocal of sine function is clearly cosecant function. So cosecant function is also periodic function. The reciprocal of sine is how much? Cosecant. The cosecant function is also a periodic function. The period of cosecant x also the period of cosecant x also 2 pi. The reciprocal of sin x, the reciprocal of sine function is clearly cosecant function. The reciprocal of sine function is clearly cosecant function. Cosecant function also periodic function, and the period of the cosecant x is 2 pi. The period of sin x is how much? The period of sin x is 2 pi, and the period of cosecant x also 2 pi. Next, let us discuss next theorem. Observe here. The cosine function theorem. The function f of x is equals to cos x. That means the cosine function is also the function f of x equals cos x is periodic. That means what? the cosine function is also a periodic function, and the period is clearly cosine function also 2 pi. The function f of x is equal to cos x. That means the cosine function is also a periodic function. Cosine function is also a periodic function, and the period is how much? 2 pi. Already we know that all the trigonometric functions are periodic functions only. All the trigonometric functions are periodic functions. Then the value of p may be different from the different functions. So here also the period of the cosine function is how much? 2 pi. Proof also here. Observe here. If f of x is equal to how much? F of x is equal to, given that f of x is equal to, given function f of x is equal to how much? Cos x. We want f of x plus p. Now we want f of x plus p. F of x plus p is equal to merely cos x plus p. If cos x is equal to cos x plus p, then the cosine function is called periodic function, and the p, the least value of p, is called what? Period of that function. The least value of the p is called what? Period of that function. Observe here, take p is equal to merely same p is equal to take pi by p is equal to pi by. If p is equal to pi, then f of x plus p is equal to f of x plus p. That means f of x plus pi by 2 is equal to clearly cos x plus pi by 2. Cos x plus pi by 2. That means cos 90. Pi by 2 means how much? 90. Cos 90 plus theta. Cos 90 plus theta. Clear, it is lies in second quadrant. In the second quadrant, cos function have negative signs. Why? Because all silver sine and its reciprocal cosecant are positive. Remaining all the trigonometric ratios are negative quantities. So cos have negative quantity, and pi by 2 is there. So cos ratio changes to sine ratio. So we get minus sine x. Minus sine x not equals to f of x. Not equals to f of x. So not f by period is not f pi by 2. If p is equals to 8 pi, so why we take value of pi and not at all take 0 value? Because p is always a positive real number and 0 is less than p and less than or equals to 2 pi. So the values of 2 pi is likely 0 and 2 pi and including 2 pi. Then the value of p is called period of the function. Period of that function. So p is always likely 0 is less than, p is less than or equals to 2. So if you substitute, not at all substitute 0. Why? Because p is a positive real number. After 0 that we substitute 90, 180 and 270 and 2. So if we substitute p is equals to pi, we get f of x plus pi. F of x plus pi means, that is, the function is cos x plus pi. Cos x plus pi means cos 180. Pi value how much? 180 degrees. Pi radians is nothing but 180 degrees. So cos 180 plus theta. Cos 180 plus theta is clearly lies in third quadrant. Cos 180 plus theta lies in third quadrant. In the third quadrant, cos ratio is clearly negative. Why? Because all silver t. In third quadrant, tan and its reciprocal, cot is positive, remaining all the trigonometric ratios are negative. So cos function is clearly negative, so minus, and 180 is there, so cos ratio can't change, we get same cos x. But here f of x is equals to plus cos x, so not equals to f of x, not equals to f of x. So pi is not a period of the given function, and if p is equals to, substitute p is equals to 3 pi by 2. That means f of x plus 3 pi by 2. F of x plus 3 pi by 2 is nothing but, that is equals to cos x plus 3 pi by 2. 3 pi by 2. 3 pi by 2 radius is nothing but 270 degrees. 3 pi by 2 radius is equals to how much? 270 degrees. So cos 270 plus theta. Cos 270 plus theta. 270 plus theta lies in fourth quadrant. In the fourth quadrant, cos is positive. So plus, but here 270 is there. cos ratio is changes to sin ratio, we get sin x. But is not equals to f of x. Clearly f of x is cos x. So 3 pi by 2 is also not a period of the recurrence. And substitute p is equals to how much? 2 pi. P is equals to 2 pi. P is equals to 2 pi. Substitute here. That is f of x plus 2. F of x plus 2 pi. That means the function is clearly cos function cos x plus 2 pi. Cos x plus 2 pi means 2 pi radians is equals to 360 degrees. Through 2 pi radians is equals to 360 degrees. 360 plus x. 360 plus theta lies in first quadrant. In the first quadrant, all the trigonometric ratios are positive. So cos x plus 2 pi. Cos x plus 2 pi, we get 2 pi. That means 360 degrees. Cos ratio not at all change. We get cos x only. That is equals to cos x means how much? F of x. Cos x means how much? F of x. That means it satisfies the condition f of x plus 2 pi is equals to f of x. F of cos x plus that is cos x plus 2 pi is equals to how much? Cos x. That means if to satisfy the condition f of x plus p, f of x plus p is equals to f of x. F of x plus p is equals to f of x. Then the cos function is cosine function is a periodic function. The cosine function is periodic function, and the period of the cosine function is the period of cos x is clearly how much? Observe here, cos x plus 2 pi is equals to cos x. So period is here how much? 2 pi is 2 pi is. The cosine function is also a periodic function. Cosine function is also a periodic function, and the period is how much? 2 pi. So the period of cos versus cos x, the period of cosine function, that is cos x, is how much? 2 pi. Clearly, here one point is that the reciprocal of cos x, that is secant x. The secant x is also secant function is also a periodic function. Similarly, the secant function is also a periodic function. Then the period of secant x, that is secant function, is also a 2 pi. The period of secant x, the period of secant function is also a how much? 2 pi. The period of sine function is 2 pi. Period of sine function is how much? 2 pi. And the period of cosecant function is also 2 pi. Cosecant x is equals to also 2 pi. And the period of cos x, that is cosine function is also 2 pi. The period of secant function is also 2 pi. The reciprocal of cos is nothing but secant. Secant function is also a periodic function, and the period is how much? 2 pi. Next theorem, that is theorem. The function f of x is equals to tan x. The function f of x is equals to tan x. F of x is equals to tan x is a periodic function. And period is next theorem. Observe here. The function f of x is equals to tan x. The function f of x is equals to tan x. That means the tangent function is also a periodic function. The tangent function is also a periodic function. The period is how much? Pi. Period is how much? Pi. Clearly, period is pi. The tangent function is also a periodic function. Already we discussed all the trigonometric functions. All the trigonometric functions are periodic functions only. But value of p may be different. So the tangent of the given function, the tangent of function is also a periodic function. The tangent function is also a periodic function. The period is clearly pi. That means proof here. Observe here. Proof. So f of x is equals to, given that f of x is equals to tan x. F of x is equals to how much? Tan x. We want f of x plus p. Now f of x plus p is nothing but tan x plus p. Tan x plus p. If tan x is equals to, that means if tan x plus p is equals to tan x, then the trigonometric function function, that is tangent function is periodic function with the period is how much? P. So the value of P compulsory, the clearly P is a positive real number. So 0 is less than P is less than or equals to 2. 0 is less than P is less than or equals to 2. So not at all 0. Why? Because P is a positive real number. Positive real number. So now f of x plus P is equals to how much? Tan x plus P. If you substitute, if P is equals to pi by, if P is equals to pi by, then f of x plus pi by, f of x plus pi by is nothing but tan x plus pi by 2. Tan x plus pi by 2, that is nothing but tan 90 plus theta. Tan 90 plus theta. 90 plus theta is lies in second quadrant. In the second quadrant, tan is negative sign. So we get minus. Here also 90 is there. So tan ratio changes to cot ratio. So we get minus cot x. So not at all, not equals to f of x. F of x plus pi by 2 is not equals to f of x. And take f of p is equals to pi. P is equals to pi. So that is equals to f of x plus pi. F of x plus pi is equals to tan of x plus pi. Tan of x plus pi. F of x plus p. F of x plus p is nothing but tan x plus p. So f of x plus pi is nothing but tan x plus pi. Already we know that pi radians is equals to 180 degrees. Pi radians is equals to how much? 180 degrees. So tan 180 plus theta. Tan 180 plus theta. Clearly 180 plus theta lies in third quadrant. In the third quadrant, tan have positive signs. So that is plus tan. Here 180 is there. So tan ratio can't change. We get again tan x is equal. So tan x is equal to how much? F of x. So f of x plus y is equal to how much? F of x. F of x plus y is equal to f of x. It satisfies the condition f of x plus p is equal to f of x plus p is equal to f of x. That's why the condition f of x plus p is equal to f of x. So tan function is periodic function. So tan x is periodic function. And the period is period of tan x is equal to how much? Clearly, the period of tan x is equal to how much? If you substitute p value 2 pi, also we get tan x plus 2 pi. Tan x plus 2 pi also we get tan x only. Tan x only. That is equal to f of x. X plus 2 pi also satisfy that condition. But we want least value of positive value of p. Least positive value of p. Least positive value of p is nothing but pi. So pi is a p, not a 2 pi. If you substitute 2 pi also we get same answer. 3 pi also same answer. 4 pi also same answer. 6 pi also same answer. But here observe here. The least value of p is called the period of the function. Least value of p is called what? Period of the function. So period of this function is how much? Pi is the period of the tangent function. Already we know that reciprocal of tangent is nothing but cotangent, that is cot x. Therefore, the cot x is also f of x equals to cot x is also a periodic function. F of x is equals to cot x is also a periodic function, and the period of cot x is equals to the period of cot x is equals to clearly period of cot x is equals to how much? So all the trigonometric functions. So all the trigonometric functions are periodic functions. Periodic function means the function f maps e to r. That means the domain is e and codomain is r. The real function f maps e to r is said to be periodic function if there exists a positive real value p such that f of x plus p is equal equals to f of x. F of x plus p is equals to f of x. We satisfy this condition, that is f of x plus p is equals to f of x. Then satisfy the condition f of x plus p is equals to f of x. Then the function is called periodic function. Then the least value of p. Then the least value of p is called the period of that function. Least value of the p is called what? Period of the function. So all the trigonometric functions are periodic functions. All the trigonometric functions are periodic functions. So period of sin x is 2 pi, and period of cos x is 2 pi, and period of tan x is pi, and period of cosecant x is clearly 2 pi, and period of secant x is also 2 pi, and period of cot x is how much? Pi. Next. Yes. While finding periods of the periodic functions, the following points are very, very useful. While finding the periods of the periodic function, the following points very, very useful. First point, that is if f is a periodic function, if f is the f of x, f is the periodic function. If f is the periodic function with period p, f is a periodic function. F is a periodic function with the period p. Then minus times of f is also a periodic function. Minus f is also a periodic function. Minus f is also a periodic function with the period first point. While finding the periods of the periodic function, the following points are very, very useful. Observe here. First point, if f is a periodic function with the period p, the period of the periodic function is p. Then minus f is also a periodic function. Minus f is also a periodic function with the period how much? P. With period p. That means example. If sin x is a periodic function, period is equal to how much? 2 pi. Sin x is a periodic function. After we discuss, sin x is a periodic function. Period is how much? 2 pi. So minus times of sin x is also a minus times of sin x is also a periodic function. Minus times of sin x is also a periodic function. Minus cos x, minus tan x, minus cosecant x, minus secant x is also a periodic function with period. How much? 2 pi. Period 2 pi. So first point, observe here. If f is the periodic function, then period is p. Then minus f is also a periodic function. Minus f is also a periodic function with period. Next, second point. If f is a periodic function, if f is the periodic function with period p, then lambda times of f, lambda is any scalar, lambda times f is also a periodic function, is also a periodic function with period. With period p1. Its period how much? p1. F is the periodic function. F is the periodic function with period how much? With period 2 pi. F is the periodic function with period 2 pi. Then lambda times of f. Lambda times of f. That means any multiples, scalar multiples of function. Any scalar multiples of function is also a periodic function with the period u1. That means, for example, sin x or cos x. Cos x is a periodic function. That is 5 cos x. 5 cos x. 5 times of cos x. What is the period of 5 cos x? 5 times of cos x. That is cos x is a periodic function. With the period 2 pi. With period 2 pi. The period of 5 cos x is also, observe here, 5 times of cos x. Cos x, that means f is the periodic function. Cos x is the periodic function. Already we know that cos x is clearly periodic function. Then lambda times of f, any scalar multiples of function, any scalar multiples of that function is also a periodic function. That means 5 cos x is also a 5 times of cos x. 5 times of cos x is also a periodic function. What is the period? Here means the period of 5 cos x is nothing but what is the period of cos x? Period of cos x is 2 pi. So 5 times of cos x is also 2 pi. 100 times of cos x is also 2 pi. 1000 times of cos x is also 2 pi. Why? Means f is a periodic function with period p. F is a periodic function with period p. Then lambda times of f. Lambda times of f or k times of f. That is lambda is any scalar times of f is always periodic function, then the period is u1. So 100 times of cos x. Cos x is a periodic function. So 100 times of cos x is also a periodic function. What is the period of 100 times of cos x is? Already we know that the period of cos x is 2 pi. So 100 times of cos x is also period is 2 pi only. 1000 times of cos x. What is the period? 2 pi only. 5 times of tan x. 5 times of tan x. What is the period of 5 times of tan x? 5 times of tan x. We know that the period of tan x is pi. 5 times of tan x is also period of pi. Tan x is a periodic function. So 5 times of tan x is also a periodic function with the same period. That means tan x period is pi. So 5 times of tan x is how much? Pi only. 100 times of tan x is how much? Pi only, period pi only. That is the second point. F is a periodic function with period p. Then lambda times of f, scalar multiples of that function, is also a periodic function with the same period. That is, take another example. 7 by 2 times of cosecant x or secant x. Secant x is a periodic function. So lambda times of secant x is also a periodic function. Then the period of this function is what is the period of secant x? Here lambda, not at all consider lambda. Why? Because lambda times of f is also same period. So 7 by 2 not at all consider here. What is the period of secant x? Secant x period is clearly 2 pi. So 7 by 2 times of secant x is also periodic function with the period 2 pi. With the period 2 pi. Understand this point? Observe here. F is a periodic function with period p. F is a periodic function with the period p. Lambda times of f. Any scalar multiples of f is also periodic function with the same period on this period. This is it. Next, third point. Yes. Third point. Observe here. In note only. Third point. If f of x is a periodic function. Important point that is, if f of x is a periodic function with period p, if f of x is a periodic function, periodic function with period p, then f of ax plus b, f of ax plus b is also a, f of ax plus b is also a periodic function. F of ax plus b is also a periodic function with period clearly, that is p by mod. P by very important point after here. If f of x is periodic function, if f of x is periodic function with period p, if f of x is periodic function with period how much? P, then f of ax plus b, f of ax plus b is also a periodic function. F of ax plus b is also a periodic function with the period p by mod a, modulus of p by modulus of. So observe here, this point is very very important point. If f of x is a periodic function, clearly f of x is a periodic function with period how much? P only. Then f of ax plus b, also a periodic function only. F of ax plus b also a periodic function only with the period p by mod a, Let us discuss one example here. Solution. Example. The period of clearly sin x is equal to how much? Sin x, that is the f of x. F of x is equal to how much? Sin x. The period of sin x is equal to how much? 2 pi. The period of sin x is 2 pi. The period of sin x is how much? 2 pi. So f of ax plus b, the period of sin ax plus b is equal to period of sin x plus b. That is f of x is a periodic function with period 2 pi. F of x is a periodic function with period 2 pi. What is the period of sin ax plus b? Sin ax plus b also a periodic function. What is the period? This clearly period is equal to p by, here given how much period? 2 pi by 2 pi by. In the ax plus b, what is the x coefficient here? Mod. So this is 2 pi by half. So sin ax plus b is equal to how much? 2 pi by half. Sin ax plus b is equal to how much? 2 pi by half. Next, period of cos x is equal to how much? 2 pi. Period of cos x is equal to 2 pi. Period of cos x is equal to how much? 2 pi. So period of cos ax plus b is equal to clearly 2 pi by, here also 2 pi by. Period of cos x is equal to how much? 2 pi. The cos x is f of x is a periodic function. Cos x is a periodic function with period p. Then cos ax plus b is also a periodic function with period 2 pi by 1. With period how much? 2 pi by 1. Next, third point here on. The period of tan x is equal to period of tan x is equal to clearly pi. Period of tan x is equal to how much? Pi. The period of tan ax plus b. Period of tan x plus b is equal to clearly pi by mod. So period of tan x is equal to how much? Period of tan x is equal to pi. So period of tan ax plus b is equal to pi by mod. Next point. The period of cot x is also pi. The period of cot x is also pi. So the period of cot ax plus b is equal to clearly pi by mod A. Period of or Ax plus B is equal to how much? Pi by mod A. Next point. The period of cosecant x is equal to how much? 2 pi. The period of cosecant x is equal to how much? 2 pi. The period of cosecant x is equal to 2 pi. So cosecant function is periodic function with period t. So the period of cosecant Ax plus b is also a, that is 2 pi by. And next point, the period of secant x is also 2 pi. Period of secant x. Secant x is a periodic function with period 2 pi. Then secant Ax plus b. The period of secant Ax plus b. The period of secant Ax plus b is equal to also 2 pi by mod A. 2 pi by. Let us discuss some more examples here. This is not. Let us understand this concept. Some more examples. Let us discuss some more examples. Observe here. How do we know that? The period of sin x is equal to how much? The period of sin x is equal to, already we know that 2 pi. The period of sin x is equal to 2 pi. We want period of sin 2x plus 3. Find period of sin 2x plus 3. Clearly it is in the form of sin ax plus b. So what is the period of sin ax plus b? Clearly 2 pi by mod a. 2 pi by mod a. That means 2 pi by, here mod a clearly 2 and 2 can cancel, we get 2 pi. So the period of sin 2x plus 3 is equal to how much? Pi 1. And second example, the period of cos 3x plus 9. We want cos 3x plus 9 period. So solution, observe here. Cos 3x plus 9. Already we know that cos ax plus b, period of cos ax plus b is equal to clearly 2 pi by mod a. 2 pi by mod a. So period of cos 3x plus 9 is equal to clearly 2 pi by mod 3, clearly 2 pi by 3. 2 pi by. Next example. Find the period of tan. Find the period of tan 3x minus 4. We want period of tan 3x minus 4. We know that tan ax plus b is equal to pi by mod a. So period is equal to clearly pi by mod a is nothing but mod 3. That is equal to pi by 3. Pi by whatever here constant is there, not that is important. We want the coefficient of x. That is pi by 3. Next example. Find the period of sin 3x by 2. Find the period of sin 3x by 2. Already we know that the period of sin ax plus b is clearly 2 pi by mod a. Sin ax plus b is how much? 2 pi by mod a. Clearly this is the form of solution. Sin 3 by 2 times of x, that is ax plus b, here we value 0. So period is equal to, we know that is 2 pi by mod a. 2 pi by mod a. Mod a, here a value how much? By 3 by 2, mod 3 by 2. That is equal to 2 pi into, its reciprocal clearly 2 by 3, that is equals to 3 by 2 is equal to how much? 2 by 3. So we get 2 2s are 4 by 3 is the period. How much? The period of sin 3x by 2. Sin 3x by 2 is how much? 4 pi by 2. The period of sin 3x by 2 is nothing but 4 pi by 2. Next example, another example. The period, find the period of cos 4x minus 9 by 5. 4x 9 minus 9 by 5 we want period. Already we know that cos ax plus b period is 2 pi by mod a. So period of first this can be written as 4x minus 9 by 5. Separate the denominator, we get 4x by 5 minus 9. 4x by 5 minus. What is the coefficient of x here? Clearly 4 by 5. What is the coefficient of x? Clearly 4 by 5. Here constant, whatever it may be, limit that one. We want coefficient of x only. So period is equals to period, clearly. Period is equals to cos x period is 2 pi by mod a. 2 pi by mod a means nothing but mod 4 by 5. That is 2 pi times of 4 by 5. Its reciprocal is clearly 5 by 5. 2 ones are 2 2s and that is equals to 5 pi by 2 is the period. 5 pi by 2 is the period. What is the period of sin x plus 100 or sin 4x plus 100 or 7x plus 100 or 7x plus 1000 or 7x plus 1 lakh? Here how much is there? Not important. We want what is the value of what is the coefficient of x. Here coefficient of x is nothing but 7. So period is equals to we know that 2 pi by mod a, that is 2 pi by mod a means clearly mod 7. So we get 2 pi by 7 is the period. So whatever it may be, sin 4x plus 1000 is not important. What is the coefficient of x here? 4. So 2 pi by mod 4 is the period. That is 2 pi by 4 is nothing but 2 ones, 2 2s. Pi by 2 is the period. That is next.